Beneath the rolling waves and above the endless blue, two realms stretch away from human reach: the deep ocean and outer space. Each is vast, uncharted, and full of enigmas that have fascinated explorers, scientists, and dreamers for centuries. Yet, when we ask which is more mysterious, we're not just choosing between water and stars. We're weighing the secrets that lie beyond our grasp, the questions that keep us searching, and the discoveries that forever change our view of existence. Let's begin with the deep ocean, a world just beneath our feet, yet so unexplored it might as well be alien. The ocean covers more than 70% of Earth's surface, and its depths plunge further than Mount Everest is tall. Light barely penetrates the uppermost layers, and at the bottom, perpetual darkness reigns. Pressure increases by 1 atmosphere every 10 meters, and by the time you reach the deepest trenches, the force is so intense, it would crush a human-made submersible like a soda can. It's in these depths, the Midnight Zone, the Abyssal Plains, and the Hadal Trenches, that the most mysterious phenomena occur. Life here is adapted to extremes. Giant squid with eyes the size of dinner plates, bioluminescent creatures glowing in the dark, and bacteria thriving in boiling hydrothermal vents that mimic conditions thought to exist on alien worlds. The Mariana Trench, the deepest known part of the ocean, drops nearly 11 kilometers down, so remote that only a handful of missions have reached its floor. Every descent uncovers new species, new chemical processes, and new geological formations. We've mapped only a tiny fraction of the ocean floor in high resolution, leaving vast regions completely unknown. But what makes the ocean so mysterious is not just its inaccessibility. It's the way it defies our expectations. The very rules of survival change with depth. Sunlight vanishes, temperatures drop near freezing, and food is scarce except for the occasional rain of organic debris from above. Yet, life persists in forms stranger than fiction, a reminder that evolution is endlessly inventive. In the ocean's depths, you'll find transparent fish, crabs with bacteria growing on their shells, and tube worms that feed on chemical energy rather than sunlight. The ocean is also a place of lost cities, shipwrecks, and ancient artifacts, human mysteries entangled with natural ones. Now, let's lift our gaze to the cosmos, the vastness beyond Earth's atmosphere. Space is infinite, or so it seems, stretching into distances that boggle the mind. Here, the mysteries are grand in scale, galaxies swirling with billions of stars, black holes devouring everything that strays too close, and planets orbiting distant suns. The nearest star is 4 light-years away, a distance so great that if you could travel as fast as the fastest spacecraft ever built, it would still take tens of thousands of years to arrive. Outer space is not empty. It teems with phenomena that challenge our understanding of physics, chemistry, and life itself. Black holes bend space and time, neutron stars spin faster than kitchen blenders, and quasars shine with the energy of 1 trillion suns. We've peered into the cosmic microwave background, the faint afterglow of the Big Bang, and found clues to the universe's birth. We've discovered exoplanets with conditions that could support life, and we've listened for signals that might hint at intelligence beyond Earth. Yet, for all our telescopes and probes, most of the universe remains hidden. Dark matter and dark energy, together making up 95% of the cosmos, are invisible, detectable only through their effects on galaxies and clusters. The edges of the observable universe are so far away that light from those regions began its journey billions of years ago, long before Earth existed. In space, the mysteries are not only about what we see, but about what we cannot. The fate of stars, the nature of time, and the possibility of life elsewhere. So, which is more mysterious, the deep ocean or outer space? To answer, we must look at the nature of the unknown. The ocean is closer, tangible, and yet still out of reach. Its mysteries are hidden beneath kilometers of water, shielded by darkness and pressure. We've sent more people to the moon than to the deepest parts of the ocean. Every expedition reveals new species, ecosystems, and geological formations, challenging our assumptions about life on Earth. The ocean's mysteries are also layered with history. It's a place where natural wonders meet human stories, sunken ships lost to storms or war, ancient trade routes, and submerged ruins. The ocean preserves the past in a way that space cannot, holding secrets about civilizations, climate, and the evolution of life itself. Its currents shape weather and climate. Its depths store carbon and heat, and its creatures form the base of food webs that sustain the planet. Outer space, meanwhile, is a frontier of imagination. Its mysteries are cosmic, fundamental, and universal. Space asks questions that challenge our place in the universe. Are we alone? How did the universe begin? What is the nature of reality? The answers often defy intuition, requiring new mathematics and physics to understand. Space exploration pushes the limits of technology and human endurance, inspiring generations to look up and wonder. Yet, the mysteries of space are also about possibility. Every new planet found in a distant solar system, every signal detected from the far reaches of the galaxy, adds to our sense of wonder. Space is the stage for our greatest scientific quests, searching for life, understanding gravity, and exploring the birth and death of stars. The unknown in space is not just a lack of information, it's an invitation to imagine. When we compare these two realms, we find striking similarities. Both the deep ocean and outer space are hostile to human life, requiring ingenuity and courage to explore. Both hold clues to the origins of life and the fate of worlds. Hydrothermal vents on the ocean floor resemble the environments of icy moons like Europa, where life might exist beneath frozen crusts. The chemistry of ocean water echoes the composition of ancient seas on Mars. The patterns of currents and tides mirror gravitational forces that shape planets and stars. Both realms are also connected in unexpected ways. The study of one often informs the other. Techniques developed to explore the ocean, like sonar mapping and autonomous vehicles, are now used in space missions. The search for extremophiles in the ocean helps scientists understand where life could exist on other planets. The cycles of water on Earth, driven by the ocean, are mirrored in the search for water on Mars and Titan. The deep ocean and outer space also share a profound psychological impact. They evoke feelings of awe, fear, and curiosity. To stare into the abyss or gaze at the stars is to confront the limits of human knowledge. Both inspire myths and stories: sea monsters, lost continents, alien civilizations, and cosmic gods. Both remind us that, for all our progress, we have only scratched the surface of what's possible. Yet, there are important differences. The ocean's mysteries are grounded in biology, chemistry, and geology. They are the mysteries of life, evolution, and Earth's history. The ocean is dynamic, changing daily with tides, currents, and storms. Its secrets are often tied to the health of the planet, climate change, biodiversity, and the cycles that sustain life. Space's mysteries are grand, abstract, and cosmic. They are the mysteries of physics, mathematics, and the universe itself. Space is static on human timescales, but dynamic over millions and billions of years. Its secrets challenge the very nature of reality: quantum mechanics, relativity, and the search for extraterrestrial intelligence. So, which is more mysterious? The answer depends on perspective. To a biologist, the ocean may hold deeper mysteries, vast ecosystems yet undiscovered, new forms of life, and the secrets of evolution. To a physicist or astronomer, space may be more mysterious: black holes, dark matter, and the possibility of other universes. But perhaps the greatest mystery is why we are drawn to both realms. What drives humans to explore the unknown, to risk life and treasure for a glimpse of what lies beyond? The answer is rooted in curiosity, imagination, and the desire to understand our place in the cosmos. In the ocean, we search for life's origins, for the limits of adaptation, for the story of Earth itself. In space, we search for the origins of the universe, for the laws that govern reality, for the possibility of neighbors among the stars. Both quests are reflections of the same drive: to know, to explore, to wonder. Consider, for example, the deep-sea vents discovered only recently, where life thrives without sunlight, feeding on chemical energy. These environments have revolutionized our understanding of biology, showing that life can exist in conditions previously thought impossible. They hint at the possibility of life on other worlds, Europa, Enceladus, and beyond, where similar environments might exist beneath icy shells. Or think of the mysteries of black holes, regions where gravity is so strong that not even light escapes. Black holes challenge our understanding of physics, leading to new theories about space, time, and the fate of information. They are the ultimate unknown, places where the laws of nature break down. Both the ocean and space are sources of inspiration for art, literature, and culture. The myths of Atlantis and cosmic journeys, the paintings of swirling seas and starry nights, the music inspired by waves and orbits, all reflect the human fascination with the mysterious. Both realms shape our dreams and ambitions, calling us to explore, discover, and imagine. Yet the practical implications of these mysteries are profound. The ocean's health is vital for climate regulation, food security, and the balance of ecosystems. Its mysteries impact our daily lives, from weather patterns to the air we breathe. The mysteries of space, in turn, drive technological innovation, satellites, GPS, communications, and the search for resources beyond Earth. Both realms present challenges and opportunities. The ocean is threatened by pollution, overfishing, and climate change. Its mysteries are at risk of being lost before they are understood. Space exploration faces technical, financial, and ethical challenges. The mysteries of both realms remind us of our responsibility as stewards and explorers. In the end, the question of which is more mysterious may be less important than the realization that both are vast, unknown, and full of wonder. The ocean and space are mirrors, reflecting the infinite possibilities of nature and the unending quest for knowledge. They teach us humility, reminding us that, for all our technology and understanding, we are still only beginning to grasp the complexity of the universe. They teach us hope, that every discovery opens new doors, every mystery invites new questions. They teach us unity, that the quest to explore connects people across cultures, generations, and disciplines. So, as we stand between the waves and the stars, we are reminded that the greatest mystery is not out there, but within us. The drive to explore, to understand, to seek answers. The deep ocean and outer space are not just places to be mapped or measured. They are realms of imagination, discovery, and transformation. And perhaps, in the end, the most mysterious thing of all is that we are part of this story, creatures of Earth, gazing into the depths and the cosmos, searching for meaning, connection, and understanding. The journey continues, and the mysteries remain, calling us onward, deeper and farther than we ever thought possible.